Alright, so we're chilling. What I'm going to be doing is just working on a type system. Well, not the type system, obviously. Type system's done already. That's Hindley Milner. But we're going to be doing, in TypeScript, by the way, we're going to be doing a basic inference algorithm. And we're going to see how it goes. I don't normally write very functional programs in TypeScript, like with ADTs and everything. So I'll do it this time. I'll see what happens. So far I've just got a couple things implemented. I figured I'd get streaming so that things work. Good enough. I assume the thing is, this thing is not really high qualitying, to be completely honest with you. Let me see why that could be. It's not supposed to downsize, so if it does, I guess that's skill issue? I don't really know. I assume it'll get better. There we go, it's better now. So anyway, what we're trying to do is first we need a data type to represent our code. So that I have already been working on. Now that's a term. Basically it's going to be a very simple term. For example, okay, I don't know why it's doing this. That's dumb. So for example, say we have the imaginary code that goes like a equals 1, b equals 2. Add is a function that takes an a and it takes some x and y and then returns x plus y, right? And then we have our result, say, which is say sum equals add ab, right? So what does this look like? Well, first of all, we have currying, right? So in reality, we can't have a function take 2 arguments yet. I want to add that, but for now, we'll do it like this. So you call it with a and then you call it with b, and it's functionally, if you think about it, it's the same thing. Kind of cool. Now, what this looks like in terms of code is it's a little something like this. And I'm gonna kind of I'm gonna write this as s expressions or something. So we do we'll do let a be, oh yeah, also I want literals. So for example, we'll do this, right? T int value number. We'll do that. So what this will look like is we'll have this sort of thing going on. I'm going to try to separate these as much as I can in 3. And now here's the thing about a let. The final term is the rest of it, right? So all of the expressions which now use a are in this rest term. So it looks a little something like this, actually. Now, we do let b be, sorry, this is not 1. This is not 3, it's 1. And now you got a new term. And another let. As you're going to notice, there are going to be a lot of lets, so I'm going to unindent this. But here's the thing about this one. Now we're going to have the function bit, right? So, what does that look like exactly is a pretty good question. We're going to have function. Now, again, functions take a single argument. We'll have the string for that. It's going to be x. And this gives you back a new function, right? Fun y. And this gives you back a call of plus with x and y passed in, right? So, call plus x, but then here's the thing, you call it again. So you call now that with y. So that's how it works. And you have add, and now of course the last thing, the last part, you might call it is there a good way we can do this? I think so. I think I can do it like this. That's our function called add, and now we will call add with, we'll use a lot of identifiers in this last one. So what we're going to do is we're going to say sum, or in other words, what's a good way to do this? Am I wrong for saying these are unnecessary parentheses? I think I'm right. Yeah. Okay, and we'll do now let sum be equal to, and again, this last bit is there's no term after that. So I guess there's not really a point of letting it be a sum. Let's just say add AB, right? So we won't even do this. We'll just say we use add in the expression, which is a call of the ident add with the ident A, and now we're going to call that with identifier B. So this is what this will look like when we parse it. And I'm not going to do the parsing today. That, I guess we'll either assume that was already done or something like that. Right? Yeah, okay. The quality, it's mad about me about the quality, but that's not that important right now. So, this is what this will look like. And so, we want to type check it. We want to look at this. We'll say, let's say, well, in this case it's fairly easy, but we want to type check this, right? We want to know what this returns. And so, we'll work on that today. And I'm not going to claim that I invented all this stuff. Of course, I'm kind of using some inspiration from other sources. Alright, so now we also have type. Type is a it's either unknown, in which case it has a special number identifier. So we'll call this in fact I'll just describe it while I'm saying it. ToString, which takes a T type, and what it'll do, I'm going to use ty, I guess, as the main thing, not too important. And what it does is it obviously gives you back a string, and what this will do is if ty.t is equal to unknown. Now, it should be smart enough here to tell me what num is. Yeah, okay, so it does, again, since script's type system sucks, it has very powerful like checking, and so it knows this is a num. When in reality, they should have just had enums with values, but whatever. Alright, so what we're going to do is we're going to say we'll just add a T to it. So we'll say, sorry, wrong way, and we'll return that as the type ToString. And otherwise, if it's known, what we're going to do is the following. So, okay, if type.name, which it should know now this exists and it's a string. Okay, cool. So if it's equal to this, which is what we're going to use for functions, right? And again, let me do some commenting here. Oh my god, I hate when it does this. I'm going to turn this off at some point. But for example, we have int equals int to int, right? I'm not sure that documentation is a good idea. You'll figure it out. Now we have our args, right? Type arguments almost. And what we're going to do there is we're going to say, in this very simple case, we know that there are going to be two type arguments. So first of all, if args ty.args.length is 0, I hate triple equals, then just return the name, because that's all there is to it. Otherwise, we're going to do it a bit special formatting for functions, because we want it to be in the format A to B, right? So we'll do return ty.args0 plus ty.args1, and that should be it. And now otherwise, what we're going to do is we're going to basically take a bunch of things and join them. That may not sound very useful, but we're going to essentially do return ty.name plus ty.args.map to string dot join plus that, and that should give you useful string for it. Nothing crazy about all that. And again, notice here we got a little bit of global mutability going on, you know, as everyone does sometimes. What we're going to do is we're going to have a new type function, which gives us a new unique type. So it gives you t1, t2, t3, t4. Essentially, the way we start the algorithm is we want to give every single term a unique type. I guess there are ways you can take shortcuts there, but we're not going to do that. We're just going to give every single term a new type. And so let's do type term.ts. And what we're going to do is we're going to export a type called type term. I'm not really messing with this album very much. I like the original. Let me go back to this. Okay. So here's the thing. It's essentially going to be type, but with an extra key on everything. It's going to be is that the way we want it? Or can we just be lazy and say here's the thing. I would like to be able to just say like type term. You know, that would be kind of nice. Probably it'll work. Import type. Cool, that's smart. We'll use TS because I'm not trying to. And then import term from term.ts. Now, the big part of this is we're going to have a function which takes a term and gives you back a type term. And that's basically going to do tree recursion in some way. It doesn't really matter which way. So it takes a term and it gives you a type term, right? But the thing is that type... Okay, wait, hold on. Let me think about this. Because a type term contains more typed terms. Yeah, this will make things a little bit weird. So... I don't see how you fix that without just defining a new type. Now maybe TypeScript has some like weird magic going on where you can do that, but I'm just not really interested in doing that. So we're going to replace all the recursion with typed term instead. Alright, hello? Are you feeling alright? And now we're going to have also TYs. So TYs are types. And now everything needs to have a type. And I mean everything. Alright. So now we want a function that takes a type, that takes, a term and returns a type term. So, term gives you back a type term. Sounds about right. The way this is going to look is we're going to, just making sure I'm not missing anything. It seems good. Recursion, right? So, it's probably good enough of a function name. We want recursion. So first we're gonna match on what the term is. So switch term.t case. Oh crap! Do I remember how to do a switch case? They're just such a weird construct. Case int. Well, here's the thing. Obviously, it's an int. I mean, that's kind of just known. So its type is int. If it's an int term, if it's a literal like number, obviously that thing's type is int. There's no question there. So to help with that, let's define some public things. We'll say export const int. I think that's a good way to do it. Export constant equals, and we'll say of course that this is a type, pardon me. It's going to have name int, and it's going to have args nothing, right? It doesn't have args, and also its t is known, of course. And that should make it a valid type. Now we'll of course do a little bit more later. Let's also do one more thing by saying export function fun. type. Now, I really don't want to. I'm not really a fan of exporting a function with a constant style name. You know, I'm going to comment this out. We'll get there when we get there. Not too important right now. Point is, this is our int type, and that's just how it is. Now, in a real program, like in a real language, this would be more of an actual path thing. I guess you could hardcode it, but generally when you do a type like this, it would have a namespaced path with modules and everything. But that's not important right now. So in here, for example, yeah, so it knows here that this is value number. Okay, that's cool. So again, it's smart enough to look into switch cases only because they're stupid and didn't design the language properly, but whatever. I'll put this one on loop. Loop-de-loop. So obviously we're going to basically return the term, but with some extra stuff. So we'll do t, obviously still int. Or we can clone it. Is that a good idea? Yeah, that's a good idea. I like that actually. So we'll do type being type.int, and of course, okay, so it exists, it just doesn't. Okay, again, it's going to get mad at me for a little bit. And now what we'll do is, and now we need to do that the typing. Is that should be enough, I think. Dot 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 term, is that how it is? There we go. That's pretty nice. Now, case ident. Now here's the thing about an identifier, we don't know, right? I mean, oh right, but didn't I say I was going to just give them random names for now? Yeah, I will for now just give them random names so that every single node has its own type. Seems like the right way to go for me. So, what do I call this? It's called new type. Okay, I'm smart. All right, that should work. Now, ident, that one's also an easy one, right? Because it's not nested or anything. Now, in the case of call, that's a little different. So what you're going to want is you're going to want ty to be, of course, a new type. But we also want to turn these types into typed terms. And the way we're going to do that is we're going to say function, and now this is where the recursion comes into play, ty.fun, and we'll say arg typed ty term.arg, pardon me. Okay, can't type today, it seems. And then we'll, of course, take the rest of it, which is just going to be the name from term. Now, why is it mad here? Now, fun is specified more than once, so this usage will be overwritten. Okay, but no, it's not, because this is, I'm not quite sure what it means by that. I don't know what exactly it wants from me here. What, you want this? Would this make you happy? Dog, what does it mean? Type term is not assignable to type term. Sure. But type gives you back a type term, and here this should be a type term. T int value number is not assignable to type term. Okay, property ty is missing in type, but required in the other type. But it's not missing. Excuse me? What's the matter here? I have to say I'm a little bit confused by what this is trying to even tell me. Um, because is arg not a typed term, and does this not want a typed term? Okay. What on earth? What? What? Well, I don't get it. What's the matter? So this usage will be overridden. Oh, does it have to do with this being some stupid top level thing? Okay, it's probably a foot gun. Let me look it up. Nope. Arg is specified more than once. So this usage will be overwritten. What the heck are you talking about? Oh, I see what it's saying. Oh my, I can't, sorry. Oh my goodness gracious. Okay. I see what it's saying. Ugh. Okay. Cool. That's just me being a little bit silly and dumb. It happens. Not a big deal. Okay. Maybe I should just put the dot dot term at the top at this point. This seems like a better choice. Okay. Okay, that's a little bit of a time loss, but that's okay. Now we'll do fun, right? So return, obviously we inherit from term, but we also say that type is a function, but again, we're not doing that yet. We're just saying new type. And now we're mapping its properties from fun, from arg. No, arg stays the same, just body. So we map the body. So we say body is typed term.body. And we also say now for case let, this is the biggest one. I haven't added let rec, but for now this is the biggest one, right? What we gotta do is say type. Well, obviously we inherit from term. Type is a new type, and then let me see if I can rack this off the top of my head. Value is gonna be typed term.value. Rest is gonna be typed term.rest. I think that should do it. Okay, that feels fine. That feels perfectly good. Now, just to test things, let's do okay, we'll import typed term and typed term typed from. Okay, and what we're gonna do is we're gonna make our term. So let t term equals. Now I want to do a kind of simple one. So we'll do, say, a function that takes x and returns 1. The thing is, that's kind of a difficult thing to do. We'll make a function that takes, sure, whatever. Yeah, okay. Okay, I'm sorry. What exactly is ident? Okay, arguably this should really be name and not value. Okay, are we feeling good now? We'll have our cont term and our type term. So let's try running it. Now I'm gonna certainly run an error. No. Good. So again, we have our types 1 and 2. Sounds about right. The top one is the function type. The bottom one is the identifier type. Fascinatingly enough. Okay. Cool. This is a bit distracting. Let's run it again. It seems okay to me. Seems perfectly fine. Okay. I mean, you could do something more complex. I don't exactly know what. Oh wait, hold on. I have an idea. Let's do if then else. I think that would be a good idea. So for that, we'll have bool. That's not going to be difficult at all. And we have a new type of term, which is an if then else. So t being if, we have our condition, which is of course going to be a term. We have our if true, we have term. If false, another term. And of course, we're kind of just going to want to copy that onto the bottom here and say tyb is a type now. And these things are all typed terms except for this one, which is type. Yeah, that seems about right. Now it shouldn't let this compile. Thank goodness. Yes, okay, cool. So, if return new type. For this one, we're going to need to map 3 things, which are going to be cond if true, if false. Okay, so cond typed term dot cond if true typed term dot if true. If false, typed term dot if false. Nothing crazy there. Now this should compile, no problem there. Alright, so we'll do this. We'll make a function that takes an argument, and then it says if that argument, then 0, else 1. Good enough. So it takes some certain thing, cond. Okay, that's not what I wanted. Let's just call it b. And what it does is it does an if. So the cond is the t-ident name if b. As you can see, it's a little bit painful to write this in object syntax, but that's kind of the way it is. There's not a lot you can do about it. So then if true, what we do is we give you back the t int value 1. And otherwise, if it's false, my bad, 0 for whatever. That's good enough in my opinion. Yeah, that certainly seems good enough to me. And obviously you need a way to actually express a boolean in the language, right? So you need bool value being a boolean, of course. I probably don't need new cases, but you know, whatever at this point. Should be good. We're chilling. So we typed it, which is very much a cool thing to do. We have 1, 2, 3, 4, and 5. Again, Memory-wise, this is very expensive, but that's because it's TypeScript and it's stupid and I have to store strings everywhere to do basic stuff. It's just the way it is. So here's the thing. We would expect this to give us the following type. We would expect this to give us a function that takes a bool and returns an int. How we can get it to that, I don't know. So we're going to be doing that today. That's the kind of goal of the day, right? Probably enough looping for now. We'll continue on with these songs. Alright, so now we're going to want the idea of a constraint, basically. Because at the end of the day, what we're going to do is recurse this tree and have a list of constraints generated by it, I think. Let me take a quick look. We also want a substitution at some point. I'm not trying to copy all this, just the basic idea. Yeah, so at the end of the day, we have a list of constraints. Which say that two types are equal to each other, right? I think that's what you want. Yeah, I mean, that seems right. Now, the real question is how do you generate those constraints, right? Because you need to look at this tree and say, for example, let's take a look. Okay, let's take a look here. What you need to do is you need to look at this and you need to say, okay, so B, the type of this, right? Well, let me think about this. Actually, that's a bit of a tricky question. My nitpicking is going to be a bit annoying here because I want to change this num to id. I think that's a more logical name. This should compile and still run. Okay. So what you want to do you want to look at this and say, for instance, that the types of 4 and 5, for instance, have to be equal to each other, right? And then you want to look at this and say, okay, well, 3 must be a bool, and therefore, now you change 1 to being, say, some 6 to 7, right? You make it a new thing, a function type 6 to 7. And you say that the int type, that's 6, must be the same as 3, right? Because those are both referring to the same thing, B. And you also know that 7 must be the same as 4, and 7 must be the same as 5. Or probably more indirectly, you'd say 7 is equal to 2, and 2 is equal to 4 and 2 is equal to 5. A bit confusing, sure, but I think the idea becomes clear in the end. So I will try to work on that. So let's do a constraint first of all. And what that looks like is you have a type called a constraint, which is basically just a replacement, right? So what you say is now what I don't fully understand is that when they, for substitution, for some reason they did a solutions rather than, a single solution, which is a bit interesting. I'm not sure exactly why. Seems like most of the time they just use from pair in this code. Like, that is certainly how it feels. Like, they never actually use a full substitution, which makes me kind of wonder why. I guess I think using a map here is a bit over engineering. I think we can just store a list of tuples and that would be good enough. So basically what it does is it takes import type ID, type ID, hello, from type.ts. What, did I not export type ID? Type var. Good enough. And what we're going to do is we're going to say it maps a type var to a type. Simple as, right? That's all there is to it. Yeah, not really too much to it there. So now I guess, wait a sec, no, hold on. I'm thinking of substitution. A constraint is just is saying one type is equal to another type. Says two types are equal. Cool. So nothing really that crazy about that. Okay, now you want something that will look at a type term and tell you the constraints. So let's do it. We'll say export function get constraints, which takes a typed term, of course, a typed term. We'll import that from, again, TS file. And it's going to return us a very nice list of constraints. So not just a single constraint, but rather a constraint list. So what this is going to look like is, as with anything else, we're going to switch on type term .t. And now we're going to look at, what exactly is, what kind of thing is it? So for example, I'd like to keep my things in order, so we'll do the same order. We'll say, first of all, if it's an int, right? Now this helps us a lot because we know that we have int, we know that we have bool, right? These are constants. What we can do is we can say, okay, this is an int, right? What we can say with this is that its type is int, right? So that we can give you a new constraint back. Now each constraint is a list, kind of, so it's a list of lists, but not important. Essentially, we just return a single constraint that says that the typed term.ty is the same as the int, right? That seems right to me. Now, if it's a bool, we do something similar. We say the type of the type term is just bool. Nothing crazy there. Now, this is where things start to get a little bit interesting. Ident. What exactly does it mean for ident to like have a type? What constraints can you do with that? And the truth is, I don't really know. I don't think there are any constraints you can do with an ident, if I'm not mistaken. Oh, but there is. But there is. Yes, absolutely there is. So here's the thing. The type of the type term, right, must be the same as the type term's body, right, dot ty. Is it body? No. Oh, that's for let. Hold on. Ident might have nothing. Yes. Okay. Pardon me. I was thinking let. Yeah, ident has nothing. Because what does it say? It says nothing new. You're just referring to a type that already exists, right? There's nothing new about that. But I don't want to copy completely off this, but let me think about this. The next one is call. Right. What does it mean? What kind of things can you figure out with a call? I think for that we're going to have to finally add this function thing. What a function from A to B, right? It's going to be a little bit weird to do this. Yeah, I guess we'll probably break some, rules about what you're allowed to export and not export, but who cares? In type, out type, and gives you back a type, and we're gonna say what is it? Is this not how I do it? Is this not how it's done? What, can you just not type the return types of these things? No. There's something weird here. This works too. I don't really care. Is out a special keyword or something? Ah, it is. Okay, right. I don't know. In type, at type. I don't really know what to say there. But essentially we're going to say t known I think that means I can probably fix this, right? So we say we just yep, coolio. I think I know is probably just better. We'll do this. T known blah 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 blah, name this blah blah blah, and then args is gonna be I and O. Cool. I don't love the different coloring, but whatever. Don't really care that much. Now, if it's a call, here's the thing. We know a couple things now. The first thing we know is that, for example, here, I can't really explain because there aren't any types where we're calling a function, but the output of the call expression is the same as the return type of the function, right? So the type term dot ty. Okay, so here's the thing. How are you so sure that it's a okay, so what they'll do is, okay, yeah, fair enough. So they kind of, instead of trying to look inside the function type, they just make this thing a function type, and I guess we'll deal with that later. So, now we import fun. And what we say is we say fun from typed from what to type term.ty? Well, of course, from the in type. is the same as typed term.fun.ty. I think that's correct. Now what else? Now here's the thing, you also want to do collect, get constraints for the typed term.arg, get constraints for the typed term function. You're going to have to do that whenever you have any recursion because you want those constraints too, otherwise this function is pretty useless. If I'm not wrong here. Okay, what's the matter here? Type constraint is not assignable to type. Okay, well it shouldn't be. There we go. Now that should work. And yet it does not. Why exactly do you think I'm trying to assign it to a type? Because it's... there we go. Now then, do we know anything else? We know that the function is the same as a thing from arg to the output type, right? We know that the arg is the same, but there isn't really much new info there. I think that's all you know. Yeah, that seems okay to me. Now what else? Fun. So this is for defining a function. You want obviously constraints for the body, right? Nothing crazy there for the typed term.body plus dot. Okay. Now the next thing you have to do is you say that the function is of the arg type. No, but that's not how it works because you don't know that's the arg type yet. You know that the body, okay, here's what you know. You know that the body type term dot, or in general, the whole thing has the same as the, no, but you don't know that. This is a bit tricky. I must say I'm confused on this one. Okay, so you have to say that it's, okay, typed, okay, so a function from a typed term .arg.ty hold on though. The function is not, but a parameter doesn't have a type, does it? How does that work? Because I was under the assumption that param type return type. Yeah, I get that. That's nothing crazy. What I have a problem with is this. So you're saying is a binder a typed type in the name string? This is very interesting. This is something I did not catch from this, I suppose, because otherwise it's not possible to implement. So I'll do this here. I'll say export type binder is name string type ty type, right? I guess. And now a function does not have a string arg anymore, nor does a let definition. So I guess this allows for let recursive let. We say this is a binder. And we say this is a binder. And I guess that's what you want. Because otherwise it just doesn't make sense. It just doesn't make any sense at all. Yeah. I mean, the thing is, that has me thinking, isn't it kind of like an identifier, but not really. So whatever. Anyway, we set a function from the type term.arg.ty. We can do this now. To the type term dot body.ty is the same as just type term.ty. There's our constraint. Now let's move on to the next thing. We have let and if. So, return. Did we ever do call? We did do call. Okay. So, of course you need the body, right? Get constraints from the typed term body. Or value is what I called it. Now, what you want to do is you want to say, okay, let me think about this. I don't want to copy, I want to think about this. Okay, so here's the first thing you know. You know that the type of the body is the type of the let expression, right? So type term dot rest dot ty, yeah, I called it the rest, is the same as type term dot ty, right? Nothing crazy there. We know also now that the let me think about this very, very much. Going to have to really think on this one. I know there's supposed to be at least one more here. Something to do with the binding? Wait a sec, this is not going to compile first of all, because I never did the binder thing here. Yeah, for these two. So really what we need here is we need a arg. We need a binder basically, right? That's mapped. So we have name being term.arg.name. And then the ty being a new type. Am I wrong for saying this? I think I'm correct for saying it. And we'll basically do the same thing here, but instead of this we do name. Okay, pardon me. That should work. Again, a little weird, but whatever. Now, what? Type term dot arg, dot name dot ty is the same as type term dot what? Value dot ty. I think that's it, right? For let. Yeah, the binding is the same as the value, and then the ty is the same. Okay, so hold on. In his normal term, does he have binding being a string? Yes, he does. Okay. So then when he does a term to type term thing, I don't think he ever showed that. Signature? What? I don't think he ever shows. Oh no, he does. This is annotate. Yeah, that seems about right to me. Already. Uh, so I guess type term, this shouldn't be a new type for ident. It should look in the environment. So what we'll do is we will have an environment, which is it's going to be by default a new map, but it's going to have type map from string to type. I think that seems correct. And so can you concat to maps.js? Oh no, don't make me do all this. I guess we'll just do this then. Can I do this? Nope, doesn't like that. Fair enough. With entry, it takes an env, and it takes ty name string ty type. And it gives it back a new env. So what this will have to do is it'll have to do a new map. Let new map equals new env equals new map. For let yeah, I'm not trying to do all this. We'll do this, and then we'll say new env dot set name ty, and then we'll return the new env. I think that should work fine. Should know this is a type string. Yep, string to type. And what we're gonna do is we're going to push these things in. So typed now has two arguments. By default, we want to give it our existing env, right? I mean, there's really no reason why we... Oh, no. Would we? Yeah, I think so. We really would want to pass this along to pretty much everything. Sure. But here's the thing. Some things introduce a new variable. Specifically, let and fun will introduce new variables. I still must tell you I'm not entirely sure. Okay, no, never mind, I am. So here's the thing. For ident, we don't want to do a new type. We want to do env dot get, or is it get? I think it's get. Okay, so what we want to do is we want to say value equals let ty equals this, and then if ty, if not ty, then basically we throw a new error. Can I just throw strings? I like throwing strings better. Please let me do it. Thank you. Throw variable not found plus term.name. Cool. That should be perfectly fine then. But now we also need to do the thing where we update the env. So we want to do, let's just call it new. That's stupid. We'll call it updated env. Haha, I'm a genius. And what this is going to look like is we're going to have, in the case of fun and let, we will define these things. So, updated env, term.arg. Okay, hold on. That. New env will do let new env equals let arg type equals new type, and what we're going to do is womp and womp. That should work pretty well. We're going to do the same sort of pattern with the let case. So we'll say let val type, I don't even know. And so within the rest, right, so rather than being a new type, we will say this is the val type. And within the rest, we use the new env, which has the term name set to the val type. That should in theory work, but oh, it's gonna hate this BS so much, dog. Why does it do this? Okay, we're gonna at this point we're just gonna come up with a new name for it because I'm not trying to yeah, this language is not a good language, but whatever. So what this is gonna look like is that we're going to be chilling. I think this is all we really need. So for example, when we do typed, assuming this even compiles, which probably it doesn't right now, default throw later lol, that should work. Now, assuming this even compiles, cool. But if now say we were to say BE, this should tell us that BE is not defined. And it does. That's pretty awesome. So, we're kind of chilling. That's pretty cool, right? That is not a bad start at all. We basically have a lexical-like variable thing checker, which is good enough for me. I mean, that's good enough for me. You could obviously go more complex and have better error messages. I'm not trying to do that right now. It just doesn't seem like something that's necessary, in all honesty. Let's finish what we left off. We have case. What other cases have we got? We have the case let. We did that. The next case is if. That's in fact our last case, if I'm not mistaken. This one we will have quite a bit of expanding to do. So for example, we're going to have get constraints like 3 times. The first time is going to be for the type term condition, right? Now, the other time is going to be for the if true. The other time is going to be for the if false. So yes, there are 3 of them. Now, we also have a couple of extra things. We know that the typed term.con.ty is bool, right? We know that the if true case is the same as the output of the it would be easier to just write it. Type term dot if false dot ty is the same as type term dot ty, and the same goes for if true. So we end up with a total of 6 cases, not even 6 like statements alone, and these are probably going to be much larger. But that means we're done. As you can see, no errors. It should compile fine and run fine. So what we're going to do now is we're going to log the constraints for this. So we're going to import constraints, get constraints basically, from constraints.ts. Very nice. And we're going to log, we'll say typed equals this, right? So we'll say typed term equals typed term. We'll say typed term. We'll say, we'll print now the constraints of the typed term. And we'll see what this gives us. This will be honestly interesting. I know what it should say in theory. Here's what it should say. It should say that obviously type 1 is the same as bool. It should say type 1 is the same as bool. Type 4 is the same as 3. Type 5 is the same as 3. And that type 1 to 3 is the same as 2. So function of 1 to 3 is the same as 2. Now let's see what it says. Alright, let's see what we've got here. 4 is the same as int. 5 is the same as int. Right, that's because these are int types. 1 is the same as bool. That's cool, that's what we expected. 5 is the same as 3. 4 is the same as 3. Yes, that seems about right to me. And now it says that 2 is the same as a function from 1 to 3. That seems pretty good. That seems right. So now we have a list of constraints, right? What we want to do now is we want to put those constraints into basically a form that makes sense, right? We want to like reduce them, so to speak. We want to basically, do these obvious operations. Like for example, when we say that the type that 4 is the same as an int, well, look at this expression. We should go in here and replace all the 4s with ints, right? But for us to be able to do that, first we need to do a little bit more smart stuff. So I think a better example would make this more clear. Let's now make a function that takes 2 things, right? And obviously the way you have to do that is you have to make a new function, right? So you need to now make a new function of tfun. And we'll make the argument, we'll call it default, right? Cond. We'll keep it simple, right? We'll have a second argument default, and we'll say that the body is this. And if it's a thing, then we do the ident name default. If I'm not mistaken, that should be good. So what we're going to do is we're going to... So looking at this, obviously default must be an int, because it's part of an if case with something else that is also an int. But this one's not so obvious. So the type checker doesn't really know that. It looks at this and it says, okay, right? It says, okay, well clearly 3 is the same as 5, and 6 is the same as 5, and 6 is the same as int. But it can't make that step and say 3 is also an int, which is what you would want it to do. So, um, so yeah, we need to make it do that somehow. And the way we're going to do that is we're going to look at these things one at a time, basically in the form of you have a type variable on one side and a type on the other side, right? You go into this constraint list and you substitute all of the types with that type variable with, well, the known type that you know it is, right? And then you not recursively, but like repeatedly do that. And the idea is that eventually you can't really do it anymore. That's at least the basic idea. Now here's the thing. I think I'm gonna go and eat lunch because I kind of want to eat lunch and like I'm hungry. I want a sandwich. So I'm gonna go and then come back and continue to work. And also my camera has stopped working. Why has my camera stopped working? Because I turned it off. I genuinely don't remember turning it off. Like, I physically flicked the switch. I don't remember doing that. But anyway, my mic's been on, so that's good enough. So anyway, as I said, I'm gonna go eat lunch. I want to eat lunch. I'm hungry. And then I will come back and keep working on this, and especially this substitution part. That's the main part. I need to figure out how to do it. When do I stop? How far do you go before you stop? I guess you stop when there is like nothing of that form type variable to type. But that's also not true. That's not helpful. So I don't know. I will get back to this.